Hello and welcome to FRQ of the day number 8. This is from the 2019 BC exam, question number 5, and it has to do with calculating derivatives and integrals. It covers a lot of that calculations stuff. So it says consider the family of functions, and it gives us this, but it's got k in it. It says k is a constant. Part A says find the value of k. It's going to be a positive number so that the slope of the line tangent at x equals 0 equals 6. So right away, I see slope of the line tangent, and I'm like, wait a minute, that's a fancy way of saying derivative. So I need to be finding the derivative of this thing. So that's what I'm going to start with doing. To take the derivative, so f prime of x, you could either do this with the quotient rule or you could rewrite it and do the chain rule. I know you guys like the quotient rule, so I'm going to do that. So we've got low d high, so derivative of 1 is 0, minus high d low, so the derivative of the bottom would be 2x minus 2. The k part, if k is a constant, the derivative of k would be 0, so I'm not going to write it. So we got low d high minus high d low, square the bottom, and away we go. All right, so I'll take the bottom and square it. If I clean this up a little bit, this whole part's going to be 0, so, and then I'll distribute this negative, so I'm going to have negative 2x plus 2 over this business squared. All right, so now that I have my derivative, I'm going to see what they want me to do with it. It says the slope of the line tangent, so the derivative at x equals 0 has to be 6. So x equals 0, I'm going to plug in 0 for x. So I'm going to have negative 2 times 0, that's 0, plus 2. This will be 0 minus 0 plus k, so that's just going to be k squared. So that's at x equals 0. And then I need that to equal 6, so I'm just going to put equals 6. And then I'm going to solve for k and see what I end up with. So when I solve for k, I'll multiply both sides by k squared. I'll get 2 equals 6k squared. Divide by 6, 2/6 is 1/3 equals k squared. So k is going to be plus or minus the square root of 1/3. Now, I always go back and reread the problem. It says find the value of k. For k greater than 0. So actually, I can knock out that negative answer. So my answer is going to be k equals positive square root of 1/3. This was a 3-point question. You got 1 point for having the denominator of f prime. Not sure why they separated it. You got another point for having the entire f prime in any form, I believe. And then you got a 3rd point for your final answer. All right, part B, it says k is going to be -8 and find this integral. Okay, so I'm going to start by writing down the problem and putting in -8. So I've got the integral from 0 to 1 of f of x, so that'll be 1 over x squared minus 2x, and then k is -8. Make sure to put a dx on there. And it just wants me to solve this. So this is not a very conceptual problem at all. It's just literally calculate that. This first thing I would try is factor the bottom and see where that gets us. That's going to be x minus 4, x plus 2. And now that I see 2 different factors on the bottom, I'm thinking partial fractions. This is a quality partial fractions problem right here. So I need to break this up into the partial fractions. So I'm going to have a over x minus 4. And then I'm going to have plus b over x plus 2. And I need to see what a and b are going to equal. So what I do is I'm going to multiply to get my common denominator. So I'd multiply the a times the x plus 2 plus b times x minus 4 And it's like getting a common denominator. Once you multiply by the missing piece, we already know what the top is supposed to equal. It's supposed to equal 1. So I'm going to put equals 1. So now I have to solve for a and b. How I do this is I choose convenient values for x to knock out one of these variables. So like if I pick, for instance, x equals -2, that's going to knock out this a part, right? Because a times 0. So then what I'm going to be left with is b times -2 minus 4, which is -6, equals 1. And then I can solve for b. So that's going to make b -1/6. And then I'll do a similar process to find a. If I choose x equals 4, that's going to knock out the b part. So I'll be left with a times 4 plus 2 is 6. This part becomes 0, equals 1. And then I could solve for a. It's going to be 1/6. So now that I have my a and b, I'm going to plug them back into my problem here. So I've got the integral from 0 to 1, and it was a over x minus 4. So 1/6 over x minus 4. Plus b over x plus 2. So that'll actually be minus 1/6 over x plus 2. Then I need a dx on there for proper notation. And then to do these antiderivatives, this is an ln antiderivative. So I'm going to get 1/6 ln of x minus 4. Make sure you put absolute value for ln. Minus 1/6 ln absolute value x plus 2. I don't need to do any reverse chain rule here because the derivative of x plus 2 would just be 1. Same over here, so I don't need to adjust this at all. And then remember, this was a definite integral, so I'm going to put my brackets, and my bounds are going to go from 0 up to 1. So my last step here is just to plug in my bounds and get an actual number out of this, if possible. So 1/6 ln, this will be 1 minus 4, minus 1/6 ln 1 plus 2. And then I'm going to be subtracting this stuff when I plug in 0. So 1/6 ln, that'll be -4, 0 minus 4, minus 1/6 ln of 2. And if I simplify this a little bit, I'll get 1/6 ln. 1 minus 4 is -3, but then we got the absolute value. So this is actually just ln of 3. Minus 1/6 ln of 1 plus 2 is 3. Then I have minus 1/6 ln, absolute value of -4 is 4. Minus minus, so that'll be plus 1/6 ln of 2. Now, this does simplify down a little bit because look, we got 1/6 ln 3 minus 1/6 ln 3. So I'm actually just going to be left with the rest of the stuff. So negative 1/6 ln 4 plus 1/6 ln 2. And you could use log rules to simplify that a little more, but you do not have to, and it is probably a waste of your time. So I would just leave it here. Quite honestly, you could leave it here, and they would have to count that because this is a number, technically. But this is a better way to put it. But they would count that correct. This was a 3-point question. You got 1 point for having the correct partial fractions. So did you get the right A and B, and did you factor correctly? You got 1 point for the correct antiderivatives with your ln's. And then you got 1 point for your answer when you plugged in the top minus bottom bounds. All right, one more piece of this. Part C says k equals 1 now, find this integral or show that it diverges. Right away, if it's giving you this option, it's gonna be an improper integral. So you're gonna have to set up like your limits and all that with your bounds. So just be on the lookout for that. It's gonna be improper. All right, and so moving down here, Sorry, I'm running out of space on my table. Let me just get a new piece of paper. There we go. Apologies. Okay, so part C, it says k equals 1. So I've got the integral from 0 to 2, and it's 1 over x squared minus 2x plus 1, because k is 1, dx. Now, first thing I would do to solve this integral is factor the bottom. It's easier to work with when it's factored. This is x minus 1 squared. And then remember, this is supposed to be an improper integral, so let's figure out why. It's because if I plug in 1 for x, 1 minus 1 is 0, so that would be dividing by 0, which is a no-no. So, and 1 is actually on our range here. It's between 0 and 2, so that's what makes this improper. So when the asymptote is in the middle of your range, you're going to split this up into pieces. So I'm going to have kind of two different integrals. I'm going to have from 0 to 1 and then from 1 to 2. But instead of writing it as a 1, we always put a variable and we say the limit, I'll just use b, you can use whatever letter you want, and I'll say the limit as b goes to 1, and this would be coming from the left, from the side with 0. The reason you have to put a limit is because if b is actually equal to 1, this thing doesn't exist. So we need to be working in a limit instead, because the limit might exist. That's what we're trying to figure out. And then I've got 1 over x minus 1 squared dx. So that's kind of the first half of it. Plus, I'll do the second half. This time I'm going to go from 1 to 2, but I'll call it b again. So from b to 2. And it's the limit as b goes to 1. This time it's from the right of this thing. So you have to have this limit notation. If it's a free response, they are expecting to see you've got some limits in there. So now I'm actually going to solve these integrals. I'm going to rewrite this a little bit. So I'll copy all this down. This is x minus 1 to the negative 2. That's going to make it easier to solve this integral. For me, at least. Because now this is a reverse chain rule integral. You could also technically do u sub, and you could make u equal x minus 1. But since the derivative of x minus 1 is just 1, this is a pretty basic reverse chain rule. So your antiderivative, you're going to take this chunk, raise the exponent, and divide. So if I raise the exponent, I'll get negative 1. Divide by negative 1. And then that's going to go from 0 to b, and we're still dealing with the limit as b goes to 1 from the left. Plus the limit as b goes to 1 from the right. Hey, it's the same exact equation, so I don't have to do my reverse chain rule twice, or I don't have to really think about it. I can just write it down. So now I need to plug in my bounds. Once you've done your antiderivative, you plug in the bounds, top minus bottom. Before I do that, I'm going to rewrite this a little bit again. This is negative 1 over x minus 1. Negative 1 over x minus 1. I just think it's easier to plug them in when it's written that way. So now, when I plug in the top minus bottom, I'm going to get negative 1 over b minus 1. It's the limit as b goes to 1 from the left. Minus negative 1 over 0 minus 1. Plus negative 1 over 2 minus 1. Minus negative 1 over b minus 1. And it's the limit as b goes to 1 from the right of that. So now I'm going to actually try to solve these limits. 1 from the left of this, if I plug in 1, that's going to go to negative 1 over 0, which does not exist. Right away, if I have a part that doesn't exist, the limit's not real here. That means this whole thing is going to be undefined. So I don't even need to simplify the rest. I can just say, because the limit as b goes to 1 from the left of this does not exist, the integral diverges. And that is my answer. If you look at why I had to write all that, the way it was phrased, it says show that it diverges, right? So I have to actually show all this work, including the fact that the limit didn't work. So just make sure you state that really clearly so you can get full credit on one like this. For the points breakdown, this was a 3 points question. You got 1 point for doing the improper integral. That means, did you break it up, and did you have the limits set up there? And then you got 1 point for the antiderivative. Did you do the reverse chain rule correctly? And did you plug in the bounds and all that? And then you got 1 point for your answer with reason. Oh, sorry, you can't see that. There we go. Answer with reason. And your reason can be the math to back it up, as long as you've labeled what you're doing clearly, showing that that limit does not exist. All right, as always, message me with any questions. Thanks for watching.